right, well, here we are, unwrapping the cosine curve. So you may recall that the sine curve had inputs of theta and outputs of sine of theta. So here, when we talk about the cosine curve, we're going to be talking about the output of cosine. So in goes an angle, out comes a trig ratio of the adjacent over the hypotenuse. So you'll notice we have the same definitions and properties that we had before. The period is going to be the distance of one complete cycle. Well, one complete cycle will relate to the horizontal stretch or shrink of the graph for how we're rotating or how fast we are spinning around that circle. Then we have the amplitude, which is still going to be half the distance of the range. So in order to find the amplitude, you should first think about the range, and we'll go from there. Because we're talking about range, this is going to be something with a vertical stretch or a shrink. The domain will be the set of all input values. Okay, so that's going to be some sort of angle. And the range is going to be the set of output values, which for us is going to be the cosine values. All right, so here's our parent function, y equals cosine of x. So let's think about that domain thing. What am I allowed to put in for x? Well, if I think about a unit circle, my inputs are always going to be angles. And if I move around the unit circle, I can take the cosine of every angle between 0 and 2 pi. There's no undefined values. If I go backwards around the unit circle, I can take the cosine of a negative angle. Well, I think from what I remember with sine, cosine should behave pretty similarly, and my domain is going to be all real numbers. Any angle that you want to, you can put in and you can find the cosine of it. Now, if I think about cosine for its range, so its outputs, when I'm here, my cosine value is 1. Then as I move along my circle, my cosine value gets closer to 0, then it gets closer to -1, then it gets closer to 0, and then back to 1. Again, if you look at the cosine values on your circle, they start at 1, decrease to 0, -1, back to 0, back to 1. So my range, my lowest cosine value is -1, and my highest cosine value is 1. If we think about the cosine of theta being the adjacent over the hypotenuse is always the biggest side. So when we find the cosine of an angle, we're always finding a smaller side divided by a bigger side, which will result in a number that is less than 1. The amplitude then is supposed to be half of the distance of the range. Well, just like sine, cosine has a range of 2. If I go from -1 to 1, I've traveled a total of 2. So my amplitude is half of that, which is just equal to 1. And the period is how long it takes to complete one full cycle. Well, one full cycle to collect all of the cosine values back to where I started is going to be 2 pi. All right, so thinking about what one period of cosine looks like, I found a YouTube video. If I can click on it, there we go. Did that work? Looks like it's trying to work. There we go. All right, so our cosine, remember cosine is talking about this x distance. So you might have missed it already, but this over here was 1, so my output is 1. On the circle, my x value gets smaller, then it gets bigger in the negative direction until I'm at my lowest point. My -1 cosine has the lowest outpoint of -1. And now my cosines are still negative, but getting closer to 0. When I'm at 3 pi over 2, my output is 0. Until I'm back to 2 pi or 6.28. When I get back to 6.28, my cosine value is back to 1, its highest point. So again, cosine starts high, goes down to its lowest value when we're at pi, -1, back to its high point. Let's watch that one more time. Getting closer to 0 at pi over 2, getting really big in the negative direction. At pi, we're at -1, getting back close to 0 when we're at the bottom of the circle, and then back to 1 as we get to 2 pi. All right, so thinking about that, we said we know we're going to complete one cycle in 2 pi. So I'm going to put my 2 pi out here. And there were 5 important points to cosine, just like there are 5 important points to sine, starting at 0, and then counting out 5 points, which would be counting out 4 intervals. So along here, these are our thetas, these are our inputs, and then our output is the cosine value of that theta. All right, so in goes 0. Well, what is the cosine of 0? The cosine of 0 is equal to 1. In goes pi over 2. What's the cosine of pi over 2? It's 0. In goes pi. What's the cosine of pi? -1. Cosine of 3 pi over 2 is 0, and the cosine of 2 pi is back to 1. So again, you see we have 5 important points for cosine, except this time we start at the maximum, midline, minimum, midline, back to the maximum. So thinking about our different features, you'll notice that our amplitude is half of the distance of the range. The whole range was 2. Amplitude is just up 1 from the midline and down 1 from the midline. Again, that midline is that x-axis in this case because we haven't shifted our graph at all. You'll also notice that it took us 2 pi to complete 1 rotation, which means that this is now my official stamp of cosine. I know that if I keep spinning around the circle, it's going to repeat that way. If I spin backwards around the circle, it's going to repeat that way. But one wave of cosine, one period, one cycle, starts up high, crosses the midline, low point, cross the midline, back up high. All right, so thinking about our different features, again, in terms of transformations, my amplitude is going to be part of that vertical stretch. So we're going to look at the A value. Multiplying on the outside creates a vertical stretch. And I'm going to take the absolute value of A because I want it to be a distance. So I need it to be a positive number. The period, we know the standard period is 2 pi. That's how long it takes if we go once around the circle at our normal pace. But if I wanted to horizontally stretch or shrink this, B is inside the function being multiplied. Any transformation that happens inside the function becomes the inverse of what I think it should be. So instead of multiplying 2b by pi, I'm going to divide by b. Okay? My horizontal shift is going to be this c value, right? That's going to shift to the left or to the right, depending on what c is. And my vertical shift will be d. That's going to move up or down, depending on what my d value is. So then these intervals, again, these are just used for counting and labeling that x-axis. If I think back to that cosine curve, I had 1, 2, 3, 4, 5 points, which means I've created 1, 2, 3, 4 intervals. So I'm going to take the total distance of a period, 2 pi, and I want to divide it by 4. The period divided by 4. The period won't always be 2 pi, so let me use the actual word. The period that I have, and I'm going to divide it by 4. Thinking about the one I just had, 2 pi divided by 4 is pi over 2. So I am counting by pi over 2's along my x-axis. Think about science class, think about labeling axes, and how you're going to figure those things out. So strategies. We want to think about having a high point cross, low point, cross, high point, right? Talking about the midline that we're crossing. This is one wave of cosine. We're going to, again, find all the things that are listed above and think about transformations. So this is one stamp of cosine, which you might be noticing looks a lot like sine, right? Those things are kind of similar. And we will investigate this connection more as we work with the sine and cosine graphs.